You know, friction. It's that thing that wears down the soles of your shoes, the reason your car tires go bald. It's that annoying force you feel when you're trying to push a heavy piece of furniture across the room. We spend so much of our time and energy trying to beat it, right? We use oil and lubricants, we design things to be more aerodynamic, all to reduce friction. But what if we actually won that fight? What if, for just a moment, friction just stopped?
Okay, so let's really get into this. Let's imagine that for 1 single minute, 60 seconds, every single type of friction, we're talking static, kinetic, rolling, fluid, you name it, is just switched off, gone. And we're not just talking about things getting a bit slippery here. This is like one of the fundamental laws of physics deciding to take a quick break. What would actually happen? Well, it wouldn't just be chaos. It would be a total cascading catastrophe, one that unravels our world in ways you probably can't even imagine.
So just so we're all on the same page, what exactly are we losing? Friction is basically the force that fights against motion whenever two things are in contact. That's the obvious stuff, like the force that keeps you from sliding out of your chair right now, but it's also the friction of air slowing things down. That's called air resistance. And it's even the internal friction that makes honey so thick and gooey compared to water. That's a kind of friction too. So when we say all friction disappears, we mean all of it. The world suddenly becomes this perfect, frictionless system, and the consequences, they're instant. Okay, to really wrap our heads around how big of a deal this is, we gotta start small. Let's forget about the entire planet for a moment. Let's just focus on you. The very second friction vanishes, your immediate personal world just falls apart. So the very first thing you'd realize, you can't move, at least not where you want to go. Walking literally depends on the friction between your shoes and the ground. You push back on the planet, and friction pushes you forward. Without that grip, your feet would just shoot out from under you. You'd be like one of those cartoon characters, you know? On a perfect sheet of ice, legs spinning, going absolutely nowhere. Any tiny push would send you sliding without any control.
All right, so you're stuck on the ground, sliding around. But believe it or not, it gets worse. You can't even grab onto something to stop yourself. I mean, think about holding your phone right now. You squeeze it, right? But it's not just the squeeze that holds it up. It's the friction from the squeeze. Take that away, no matter how hard you grip, that phone is just gonna slide right out of your hand as if your fingers were greased. Same goes for a coffee cup, a pen, everything. The very idea of grip is just gone.
And this whole problem gets weirdly specific. Take your shoelaces. Who thinks about shoelace physics, right? But a knot only holds because of the friction between the laces. That's what keeps it from slipping apart. The moment friction is gone, the tension in the loops would just pull them straight, instantly. Every single knot on Earth would just unravel.
And that brings us to, well, probably the most awkward part of this whole thing. Your clothes. They're made of threads, which are made of tiny fibers, all twisted and woven together. And what do you think holds all that together? Yep, friction. Without it, the fabric itself would just lose its structure. It would start to come apart, thread by thread. So yeah, in just a few seconds, you're naked, you can't move, and you can't hold anything. And trust me, we are just getting started.
Okay, so from that personal nightmare, let's zoom out a bit. Let's look at our entire civilization. It turns out that everything we have ever built, from a simple wooden chair to the tallest skyscraper, is basically glued together by the very force we just got rid of. Just look at this thing, the simple, humble screw. It's one of the most important inventions in all of human history. It lets us turn a little bit of rotation into a massive amount of clamping force. But the real genius of a screw isn't just that you can tighten it, it's that it stays tight. And that little superpower is 100% dependent on friction. There's this quote from one of our sources that just nails it, and it's pretty chilling. A Titan bolt is basically a spring that's been stretched, and it's holding a ton of stored energy. Friction is the little latch that keeps that spring from releasing. The moment friction vanishes, the latch is gone. Every single nut, bolt, screw, and nail on the planet would instantly and violently pop out of place. Think about it. Buildings, bridges, airplanes, everything we've ever built would just come apart.
So what about stuff that's already in motion? Let's say you're driving your car. Your brakes work because high friction pads clamp down on a spinning disc, turning all that motion into heat. No friction? The pads just slide, no stopping. And steering? That's even more dependent on friction. The grip between your tires and the road is what lets you turn. Without it, turning the wheel does absolutely nothing. Your car just keeps going in a perfectly straight line. So every car, every truck, every train on the planet instantly becomes a runaway projectile. You can't stop it, you can't steer it.
And this collapse would hit our industrial world just as fast. Power plants, factories, you name it. Bearings that let things spin smoothly would fail. The teeth on gears would just slip right past each other without churning anything. And cooling fans, they need to grip the air to push it. Without friction, they just spin around doing nothing, while all of our most important machinery overheats and destroys itself. Basically, the entire engine of our civilization would grind to a halt and just melt. Okay, so your personal world is a mess. Our entire civilization has literally fallen to pieces. You'd think that's the worst of it, right? Oh no, the chaos is far from over.
Now we have to deal with the planet itself, because the very ground under our feet is also held together by friction.
Somebody on Reddit actually put it perfectly, just brutally simple. Think about a pile of sand, or even a mountain. It's only stable because of the friction between all the little bits of rock and dirt. That creates something called the angle of repose. It's the steepest a slope can be before it collapses. Without friction, that angle drops to zero. Everything goes flat. Gravity just takes over. And this is where things go from disaster to something biblical. We're talking about a cascade of geological events that are almost impossible to imagine. First, the tectonic plates. They're all grinding against each other, held in place by massive amounts of friction. All that friction just disappears, so every fault line on Earth would slip all at once. A single planet-wide earthquake. At the same time, every hill, every mountain, every slope on Earth would collapse into what one person called an ocean of mud. And under the oceans, those massive landslides would create tsunamis of unimaginable size, racing towards every single coastline on the planet.
So, after a full minute of this absolute planetary chaos, you might be thinking, phew, okay, friction's coming back, we're saved. Well, you would be so wrong. The single most destructive moment in this entire nightmare scenario isn't during the minute without friction, it's the exact second it comes back.
Just think about that moment, the 61st second. Everything on the entire planet that has been sliding and falling and accelerating for 60 seconds is about to get stopped dead in its tracks. Okay, so here's how it goes down. For that whole minute, everything that's moving, cars, landslides, entire tectonic plates, has been building up a truly insane amount of kinetic energy, the energy of motion. At second number 61, friction snaps back into existence. It's like the universe slams on the brakes for everything, everywhere, all at once. And we all know that basic rule from physics class, right? Energy can't just disappear, it has to go somewhere. Well, in this case, all of that unimaginable energy of motion gets converted instantly into heat. Lots and lots of heat. And this leads to this absolutely terrifying thing that scientists call flash temperature. It's a massive, instantaneous spike in temperature right at the surface where things stop sliding. We're talking about enough heat to melt steel, to vaporize rock. The world doesn't just stop moving, it bursts into flames. A planet-wide firestorm caused by the violent return of the one force that was holding everything together in the first place.
Okay, wow. So after walking through that absolute apocalypse, it's pretty clear this whole thought experiment isn't just some fun party trick with physics, right? It's a really powerful reminder of just how much we owe to this humble, invisible force that we are constantly trying to get rid of.
There's this one quote that I think just sums it all up perfectly. We always think of friction as a problem, as something inefficient we have to overcome. But seeing what a world without it looks like, it shows us it's the exact opposite. It is the anchor. It's what gives our world stability and structure. It's what makes everything we know possible. Get this, some studies estimate that about 20% of all the energy the world produces is spent just to overcome friction in our cars, in our machines, everywhere. And at first, that sounds like a huge waste, doesn't it? But after what we've just talked about, it doesn't sound like waste at all. It sounds like the price we pay to keep the world from falling apart.
So in the end, this whole crazy scenario shows us that friction isn't some annoying flaw in the universe. It's a feature. Maybe the feature. The thing that allows for any kind of complexity or stability to exist at all. And its absence for just 60 seconds would completely erase everything. Which leaves us with one last big question to chew on. If a force this important can be hiding in plain sight, what other invisible forces in physics and biology, maybe even in our societies, are we completely taking for granted? What other anchors are holding our world together right now without us even noticing?